Hey everyone, it's Jim
and Charles
from Mellow amps. And we're going to keep on populating this PCB until we have an OTL amp. And so you've been doing a lot of little jobs, and we've been sort of working up until we're feeling confident about doing a bigger and more difficult soldering job. Probably the trickiest of all the jobs, and that's getting the sockets on. Not only soldering them on, but soldering them on the right side of the board in the right orientation. So caution everyone, pay attention to this episode. Don't leap ahead and solder them on. There's a very good chance you'll put them on the wrong way and you'll wreck your board basically. And you'll have to start over again. So a couple of minutes and we'll get you oriented. And don't make any presumptions about the orientation because it'll probably be wrong. So when manufacturers started labeling sockets, tube sockets, here's an octal socket. These are fabulous. They're well made, long lived. They have a sort of a pinching mechanism that just lasts and lasts. And it actually cuts the pin of the tube as it goes in a little bit, which helps make for a very solid electrical connection. So when they had to come up with a numbering standard for the pins, what they did was they decided that all of the pins were going to be done from the orientation of the builder or the assembly bench. It's the only thing that makes sense, right? So pin 1 is actually where you think the last pin would be. So turn over your socket, try and orient it the same way I've got it. You see the keyway here? To the left of the keyway is pin 1, and that's always the way it's done. So get a Sharpie and come in here and just put a 1 right there. Let me turn that over to the left of the keyway. It's pin 1. So if I turn this over, pin 1 is over here, right? There it is. You see why I say it's probably reversed from what you think it is? Okay, now Charles is going to prep the socket so that it's ready to go in. So a nice pair of flat pliers really makes easy work of this.
So something like these guys right here. You can use other pliers, but these work great. And we just want to give each one of these little legs just a small bend inward on 90 degrees. So yeah. Just going to come in here just like this.
Yeah, so the legs all should be at about 90 degrees.
Just a little bit there.
Now you might notice how the legs have sort of a nice little kick out. That's all part of the design. Don't take that out of the pin. You want that to be in place.
And these pins work hardened very easily. So no bending back and forth, no wiggling them. You want to do one.
What? No fun?
Little bend and then get off of them. And all we're doing here is making sure that it's going to drop right into...
So we can't play with our sockets?
A little bit. You can get away with a little bit. Okay, I think that looks pretty good. Now we're going to look at our number 1 here. Sorry, it's a little washed out on the camera. And then we're going to align that with the number 1 on the board. And I'm actually going to move the build stand out of the way.
Mounting them in the corners here in that little notch is really a great spot. In fact, let's put the other one over too. There we go.
And then I'm going to keep that number 1 alignment. And I'm going to drop it in here.
Oh, you should show the labeling on the board because people have actually put sockets on the wrong side.
Install socket here. If I flip it over,
there's nothing.
It's giving the number of the socket and the pin numbers, which are useful.
Yeah, for testing.
But install it on the correct side of the board, the side with the RCA jacks. Okay, let's come back in here. And you'll have to work your way around and seat each one of the pins in. So I'm going to go here.
Yeah, so use your favorite poker. It actually is a lot easier than it looks.
Each of the pins have a fair bit of wiggle room to them.
As by design. Charles has designed so many of these PCBs over the years that he's basically the pro.
So let's take a look at that. Let's
do a side view.
There we go.
Now you see how it sits down, but it actually doesn't sit tight to the board? That's the way it's supposed to be. Don't push it on any harder than that. Mm-hmm. That's the height that we're looking for. There's a plus and minus, so you don't need to stress about the height. Just so long as you're snug, you're good.
So it's still very loose here. See, if I let it go, we're going to fall right out. So next step is we're going to come in with a set of flat pliers, and we're going to carefully bend over these leads to hold it in place. And this is the point where you can very easily scratch up and mark up your board.
Yeah.
So go slow, take your time, and try not to slip. I'm just going to go.
I actually just grab them with the pliers and bend them over. It's easier.
Yeah, let's give that a try then.
For years, I would just shove them over, and then I would slip, and I would scratch the board.
There we go.
You don't have to, in fact, you don't want to push them over hard. About 45 degrees is good.
Something like that. And I'm going to work around sort of in a cross shape here.
Yeah, so basically what Charles has done is he's got essentially 4 corners, and now he's going to come in and do the diagonals in between. And all the while, he's got his finger on the back side, and he's holding the socket in place. So he's pressing up a little bit. It is going to wiggle around a little bit, so don't fuss with that. That's just normal.
There we go.
So let's have a quick look to see if everything is right. I'm going to show you the orientation a couple of times. So here's the front of the PCB. This is, of course, the top or the up face. Here's the back. It's got all of our power supply, filtering, and all that good stuff. And you can see that if you're at the front here and you're looking back, the keyway is facing to the rear of the board, and it's just a little bit
off on a slight angle.
So I would say it's at the 1 o'clock position. So that's how your both sockets should be on the board. Now, we're going to bring the heat up a little bit because there's quite a bit of mass to solder on, and we're going to actually flow a lot of solder because we want a good electrical connection, and the solder is going to partly act as a glue and a stopper to make sure that the sockets stay put, because they take a fair amount of force when you push a tube in and you pull a tube out.
And we want to make sure we get some good flux on them too.
So I think we're going to come up to 380C, which is about 710 Fahrenheit.
Okay, and let's get some flux on those pins.
I thought all I had to do is talk in this episode. You're going to make me work.
And we're not going to tack on all of them at the same time. We're going to get one on there and take a look at how it's sitting, and then we'll come back in and work our way around.
And you really don't need that much flux. In fact, you do not want to put that much flux. A little bit goes a long way. Once the heat hits the flux, it just melts and it etches the surface that it's touching, and it just flows out beautifully. And of course, that etching process is what creates a clean and really doable bond for the solder.
Okay, so I've got a nice clean tip. I'm going to tin it, and I'm going to come in on number 1 here, pressing hard into the pin and into the pad, and then we're going to flow a fair amount of solder onto it. And
now, Charles is holding for about 1.5 seconds. We're going to have a look at the other side to see if we got good flow through.
We have beautiful flow through. Let me get that in focus there. That's ideal. That is exactly what it should look like.
Yeah. You would really like to have a decent amount of flow through.
Okay. And if you take a look here, our socket is actually on a slight angle at the moment. So that's not something that we want. So I'm going to tweak it just a little bit. Sorry, I can't show you that on camera here. One moment. So I'm going to straighten it up. And I might actually need an extra set of hands while we're doing this. So yeah. I'm going to hold this in place.
I think what we will do is we're actually going to reheat one. And we're just
push it up.
We're just going to push it up.
Okay.
There we go.
Okay. Hear that little click?
So it was down maybe 0.5 millimeter. It really wasn't off very much.
And
it doesn't have to be absolutely perfect. I think we're pretty close.
that's quite a bit better. Okay. So now I'm going to do the opposite pin on number 5 here. Then we'll take another quick look.
Yeah, we'll do one more, and then we'll come back and we'll show you what to do if you don't quite have enough solder.
Okay.
That's looking excellent.
Looking good. And we've got good flow through on the front. And now let's do one of them without flowing enough.
Well, we're probably going to end up with something somewhere like that. So,
Okay, we'll do the rest of the pins and we'll pop back in and show you what that looks like.
yeah, so what would be the sequence you would do? I think I would go 3, 7.
Yep.
And then you can just do your diagonals. Okay, we'll see you back in a minute. Well, it's going to take you a few minutes. But anyways, take your time, do a neat job. Okay, so let's take a look at what to do if you don't quite have good flow through.
So pins number 2 and 3 here. You can see we don't have a nice solder blob holding the pin down, and that's really important with these sockets because they're going to get the most wear and tear on the whole amplifier. So on this side of the board, I'm going to come in again with a clean iron. We're still at the same 380 degrees Celsius, which is about 710 Fahrenheit, around there.
Yeah.
And I'm just going to come in on the pin and the pad over here.
Now the socket is ceramic, so you don't need to worry about putting heat into it, but you're right near the capacitor, so watch out. Don't accidentally nick the capacitor with your iron.
And it's as simple as that.
Now what if you didn't get enough solder on the other side of the board? You really don't want to go scant here. So I'm looking at number 4 and I'm thinking that it's enough. It probably would pass, but
let's add just a touch more and show you what it looks like. So I'm going to come in here.
reworking at this stage is easy. It's quick.
I'm just going to heat it up and drop a touch more.
And that's it. You get in and you get out fast. When you're trying to fill in large areas of solder like this, you come in with a lot of heat and you apply a lot of solder very quickly and you get off very quickly.
So there we go. So we have one socket installed, and now just do the other one the same way. Be very careful. Pay careful attention to the alignment, just like we did with the first one. Mark your socket so you know which pin is pin 1.
Yep.
And do it the exact same way, and we'll see you back here in a bit.
Yep. Okay, one last job before we wrap up this episode. And before we move on, let's just take a look at the orientation of the caps. You can see the keyway, how it's sitting at the 1 o'clock position if you're facing the front of the amp. The MTA is actually at the front of the amp. And now, one of the trickiest things, or biggest pitas going, is breaking in sockets.
They're very stiff when they're new, which is a good thing because it means that you're going to have a good connection.
So we've come up with a new method, and what we do is we've always liked to use a junk tube. You do not want to use a brand new tube or a high quality vintage tube. So underneath here we've got a resistor right here, so we don't want to be pressing on these resistors. So this is a job to get somebody to give you a hand. So what we're going to do is we're going to mount it right on the edge of the board, and I'm going to keep the resistor off the board because I don't want to damage it.
And we're going to take a junk tube, and again, if you need one of these to break it in, just ask us. We have piles of them around. We'll send one out. And we're going to line up its keyway with the keyway here. And we're going to press it down hard. And there we go. Now I'm going to pull that.
And we're going to do it a second time.
Do it a second time.
And now
it's easier.
And now we're broken in.
Now we're broken in.
And go ahead and do the other one. And
that one's even a little stiffer. There we go. And this is why it's better to do it before you have the amp complete. You don't want to be putting that kind of pressure on the amp. And that's it. Bob's your uncle.
Okay, well done, everyone. This actually is the hardest soldering job of the whole project. So yeah, from now on, it's just downhill, eh, Charles? Okay, well, let's carry on.